Okay, so this is week 3, which we are on chapter 3 on the.
That was perfect timing, though. Something that was.
Some people might think that's a sexual orientation.
Oh, we missed one now. Okay.
Oh, he's on the way here.
Okay. Week 3, chapter 3 in the book. Please read carefully through it. I will go through the book page by page, and maybe you can help by highlighting the stuff that are important to remember, because all these numbers do come in the oil burner exam, if you were to take it. So chapter 3 in the NORA book, chapter 15 of the electricity book. I think Bill, HVAC electrical application, he covered the last 6 chapters of the Russell Smith book. So he's going to cover that in HVAC electrical applications. So I'm not going to go over it a lot. So combustion, if we were to, currently in New England, if we were to produce heat in a house, we still relying on combustion. We're either burning wood, gas, or oil. That is still available. Even if you have a heat pump, probably you have emergency heat as a backup for January and February, because it gets really cold and the heat pump does not cover up the heat. It can subsidize, but it's not going to be the main source of heat. Very manual. What is atomizing? So we need the correct mixture of fuel. What is the equation of combustion? Fuel plus air plus spark will give you heat, CO2, and water. I'm going to write it down. Are we doing combustion in our body? Yes. We are. What is our fuel?
Food.
So in our bodies, guys, let's pay attention. Fuel is your food. You're breathing air, oxygen. There's no spark, there's enzymes that start to burn the food, and we still have heat. That's how your body produces heat, and we breathe out CO2 and water. It's kind of similar. So combustion or burning fuel to produce heat is something you can do biologically, or we can do by actually making fire. So we need the right mixture of fuel and air. Why? Because we want complete combustion. If there is no complete combustion, if you have too much fuel or too much air, what would you have? You'll have smoke, you'll have CO, you'll have nitrogen oxide and sulfuric oxide from the fuel. So we always need the right amount of fuel mixture, the right amount of mixture and proportion for air and fuel, otherwise you're going to have some excess. If there is some smoke, there must be some excess in the fuel or excess in the air. So too much air is not good, too much fuel is not good, so you need to have the right balance. What is atomizing? It's a general term because atom is the smallest form of material. So atomizing is a term that's used to break down the fuel into small little particles. So when we deal with liquid, it's really hard to burn liquid. I bet you can throw a match in a fuel oil and it will not light or ignite at the right temperature. Let's say, what is the flash point? That's the point when the oil starts to become vapor. It will not ignite 100 degrees. That's when it starts to flash, become vapor. So at that point, maybe if you throw a match, it will ignite. If it's at room temperature, which is around 60 or 70, you can throw a match in oil and it will not burn because it not reach the flash point. When we do atomizing, we basically break down the fuel to small little droplets that sprays out and become very small, and in that term it will be easier to evaporate and ignite. So this is what we do when we atomize. What do we use for atomizing?
Those little pellets that are.
The nozzle.
The nozzle. So the nozzle is what it does. Using pressure, it will push the fluid through a small orifice that only small droplets will come through. So you mix the air coming inside the burner with those atoms and becomes more loose, and you have more surface area and more probability to burn the fuel. So what is clean combustion? Is when we burn the fuel 100% and there is no excess fuel. If you're not burning all the fuel, you're gonna have incomplete combustion, and that will lead to having smoke. How do you fix that? You adjust what? The air. So when you had a carburetor, did anybody work with a carburetor ever before? Yeah. So if the car is smoking, all cars without the catalytic converter, you will go and adjust the air until you stop seeing smoke. We'll do the same thing here in oil burners. If it's smoky, that means you have little air, so you adjust the air using the air vent. What is the ignition point of fuel oil? We talked about it last class. It's in the book.
500.
I'm gonna go with the book. The ignition point is more than 500 degrees Fahrenheit. So I think 637, I've seen that somewhere in the CMR, but anything above 500. This is very exact for some fuel, but I'll go with more than 500. Let's go with the book and make it. Just to be consistent.
So the ignition point of fuel is when,
Yeah, that's when the fuel starts to burn. So, if we heat the fuel without spark to 500 degrees or 600 degrees, would it burn? It will, no, it will start to self-combust. Yeah, it will start burning. That's why when you cook when you fry a turkey, we're trying to fry for some food, and the oil is above 400 degrees, if you keep increasing the temperature, eventually it will just catch on fire without even a spark. Huh?
That's
No,
not
luckily. Because, I pay attention to these things. So you'll start, if you hit like a pot full of oil, you'll start seeing the oil start to rise, becoming vaporized, and it gets really hot. If it gets a little bit too hot, it will suddenly ignite. That's why they tell you when you fry, try to reach temperature between 370 for canola oil, and if you use peanut oil, probably around like 400. If you exceed that now, you have the more possibility of having the whole thing catch on fire. If one drop falls into the stove, it reaches the ignition point, it's gonna start to spark, and that can reach out. You have a lot of fumes around the pot, it will catch up on fire, and this is how the whole thing goes on fire. What do you do? Under no circumstances, do not put water in there.
Turn it off.
Turn it off and smother it. That's your best bet. When you smother something, you stop the oxygen from coming, it will suffocate and stop. Do not panic and just go pour some water on it. Oil burner types. This is some historical types about oil burners. There's a vaporizing burners where you have a wick to burn or a set of wicks. So it's kind of like a candle. When you burn a candle, the wick burns first and it melts the oil around it, and start using capillary effect by pulling oil or liquid into the wick and burning it. So this was the beginning. Before we have burners, we had vaporizing burners. Some of them are gravity fed, so you have the tank on the top. So you can have a tank of oil here. And that will push the oil out. Kerosene burns cleaner than fuel oil, so usually they are kerosene, and they used to use those for light and sometimes for cooking. Back in the days, somebody used to go and light all the lamps in the street using oil, and they filled them with oil. If you look at those old movies, you see somebody goes at dusk and light all the lamps. So the gravity fit. There's always issues with soot, because again, it's really hard to get complete combustion using wicks. The wicks gets too long or too small, and you are going to have some soot. Again, think of the candle. If the wick gets too long, you start having a lot of fire and some soot coming up. And if it's too short, you'll have also some smoke and soot. So they always have issues with soot. They are still used in France and Japan for some reason, in some further areas, because of convenience of the location, and also because earthquakes. So in some areas they still use those gravity fed vaporizing burners. We have low pressure burners between 1 and 15 psi. What is the pressure for our burners? 100 to 150 psi. So there are low pressure burners. You can either pressure the oil or they introduce pressurized air into the system. So there are two ways to introduce pressure into the system. Either you pressurize air and have the air push in the oil as it goes out, or you can pressurize the oil itself. So if you look at spray painting, if you have a spray paint can, what are you pressurizing? The air. The pressurized air will push the fluid with it and spray it. If you have, if you were to paint a wall and you rented the compressor actually this is what the compressor can looks like. There's a hose and a small nozzle here, and a can. So you fill the can with paint. Now, what would happen? You have a lot of pressure coming out here.
The pressure is going to suck the paint out.
So the pressure here will provide a vacuum. The vacuum will pull the paint out, and it will spray the paint.
You're a hell of an artist, man.
Huh?
You're a hell of an artist, bro.
Try. Paint. So this is how you use a pressure nozzle to spray paint something. So again, you can pressurize the air, or you can pressurize the oil. What are we doing for residential? What are we pressurizing? The oil. So the pressure goes into the oil, or you're using the oil pump, and it will push through the nozzle and spray out, and the air comes in as secondary air. So a lot of fuel pumps can have high pressure, almost 100 psi, sometimes 150. Those are high pressure boilers. They are mainly industrials, if you're going to have a lot of high pressure boilers. Have had changes in operation since 1930s, the same technology, same idea, how to pressurize oil. Few changes in terms of transformers, nozzles, and burner size. So if you look at the burner made in the 1920s, you're going to see the same anatomy, the same components. We changed the transformers. Now they do not constantly ignite. They ignite then stop. The nozzle has changed significantly. They are more efficient. They can do more atomizing. And the burner size has changed. It used to be really large. Now it's small because we can confine the fire and contain the heat, which will make it more efficient. But the main components always remain the same. Nozzle and flame shape relation. So you take the nozzle. Where did I put that? So if we look at the nozzle here, the fuel being pushed, okay, this is inside the nozzle tip, oil is coming. It push through the filter first. What is the purpose of this little filter or little strainer?
Optimizing.
It's gonna streamline it, make it stream a small little droplet so it will flow through it. And it will go here, and there is a small plate that pushes the oil through it, and it will spread.
They send me right back out of there.
So this will go through, and if we look at any nozzle, you'll see two things. I'm gonna pass those two nozzles. I want them back. If you look inside, you'll see the anatomy. Jack. You'll see the anatomy of the nozzle and how is it pushing the fuel through. And this is one that's not cut up. So I'm gonna pass it through. So, come on. There are two things on the nozzle: the flow rate and the spray angle. So the way we spray the oil will kind of define the cloud and the amount of flame we have. We want the flame as contained as possible. We don't want it to be spread out. You don't want the flame to be touching any wall in the chamber. Keep that in mind. If it's touching the wall, something is wrong. You're going to have some kind of smoke. So you want the flame to be inside the chamber. If this is my chamber for the boiler, and this is my oil burner, you want the flame to be in the middle. You don't want it touching the back. You don't want it touching any of the walls. Yeah.
How would you know if it is hitting the back though?
You can look at it, and if the burner is designed to have certain GPM and certain pressure and also certain angle. If you change any of these things, you're going to change the shape of the flame, and that will make the flame touches the walls. If it touches the wall, you might crack the boiler, you might have smoke. If you have smoke, probably something has changed. Check that the nozzle and the flame and the nozzle and the pressure is correct. So the nozzle and the shape of the flame has a really strong relationship, and also the amount of air coming into the chamber. There's something called the turbulator or the diffuser. Yeah.
Why is there a temperature on that one there?
There's no temperature. That's the 60 degrees. That's the spray angle.
Ah, okay.
The spray angle. So if we look at the spray angle, this is my nozzle. If you measure this, it's 60 degrees.
Yeah.
You can have 90
Okay.
and so on. I think it varies from 120 to 30 degrees. How much does it spray? If you look at the spray bottle with the twisted tip, if you twist it more, you get it closer, it will spray further. If you make it very far, it will go straight in a streamline. Same thing with the garden hose.
Yeah.
If you switch the
Yeah.
distance, it will change the shape. So the same thing happening here with the nozzle. The nozzle is very sensitive. If you drop it, then you have to change it. Try not to touch it with your hand because you don't want some oils in it. If it's scratched up, it will screw up the angle, so you don't want that. And also the strainer inside should always be clean. And every time we do maintenance or preventive maintenance or checkup or tune-up, you have to change the nozzle. They're not expensive, but and sometimes they work, but they don't give you the right spray. So there are something called stabilizers, chokes, diffusers, and turbulators. What are those? They're all named for the same thing. Let me see. This basically is a plate that they put up front of the burner just to shape the air. So if you come in here, probably you'll see a little plate that will give the air some swirl, kind of a tornado effect, so it will contain the flame inside, in the middle, and not go sideways. Yeah.
Didn't we see that in the lab?
Yeah. So we need to work with it, and you can see it. But it's called different names depending on the industry: stabilizers, chokes, diffusers, and turbulator. So this is the flame without flame retention. Flame retention again is the turbulator. So in this case, this is going all over the place. It's hitting the walls. It's not really streamlined. And this one you have the turbulator plate and the spray angle coming the right distance to the chamber. And the flame will be produced inside the chamber. It's not touching any of the walls. And that will make you think a little bit. What is the purpose of having the correct distance from the chamber and also the correct distance from the plate? We saw before when we adjusted the nozzle, the nozzle is too close to the electrodes. If they are too close to the turbulator, they will spark into the turbulator. So you want to be the right distance. So if you have no ignition, you probably want to check your clearances here and here and make sure they are the same distance from the plate. The correct distance from the plate, and the flames going inside and not touching anything. Combustion air comes in with the fuel. As you can see, it comes from around the fuel. It hits the diffuser and it goes out. Fuel comes in from the nozzle, and we have spark. So we get the spark, we get the fuel, we get the air. All the three elements of combustion happening here, and hopefully, not hopefully, it should be designed well. But when you take it apart, put it back again, hopefully you put it correctly and you get the same shape of flame. If you see some drips in here, some drops of oil, you know something is not right, and the fuel might be hitting the turbulator plate before it goes out. So you can see how the angle is very important. It's supposed to fork in here and goes out. If it's a little bit further, it's going to hit the plate, and you have some after drip inside the chamber, and that is not good at all. Question about that? We did take a whole burner apart and put it again, so we know what it looks like.
But,
Yeah.
so, are you running is any, the question about
Yeah, they'll ask you about the angle, what is the purpose of the angle, what is the purpose of the turbulator.
So 60 degrees?
No, it always depends on the manufacturer specification. So you always stick with whatever printed on the burner. It should say on it what is the spray angle and what is the
And do you
pressure.
measure the fuel?
Say it again?
How do you check the angle?
The angle should be printed on the nozzle. You see the nozzle that I passed around? Look at it. It will show the angle on it. So this is the flame retention system. So conventional, usually you'll have a flame that's spreading out. And if you have flame retention, you'll see the fire going into a spiral, which is more contained and still the same heat. This modification has been there since the 60s, and people trying always to modify on it, because the more you modify the air and the fuel mixture, the better fire you'll have. The flame is held close to the burner. However, you don't want it to be inside. If you have the flame coming from the inside here, you will overheat the electrodes, and you might also burn your cat cell. Where's your cat cell? Where's your cat cell?
Behind.
It's here. Usually it's here. It will see the flame and the light, but should not be close to the heat. So any portion to the right of the flame should be not that hot. It should be warm but not hot. All the heat should be come here, should be in here in the flame. Where is the hottest part of the flame?
Tip.
Huh?
The tip.
Usually in here, not the real tip, but the end of the blue part or the main glowing part. So it provides a swirl to the air, kind of a tornado effect, and that will keep the fire contained. It has the potential of improving efficiency from 5 to 15%. Why? Because we're getting more fuel burnt at the right temperature, and you're losing less fuel. So 5 to 15% is significant. We have more heat and less excess air, because you don't want the air to be going all over the place. So you get the correct amount of air using a turbulator on flame retention. If you go and see a burner without a flame retention, you might want to go and replace that with something that has flame retention. Increase of temperature from 300 to 500 degrees Fahrenheit inside the chamber. So the flame will always going to be around 600 or 500. However, you want the entire chamber to be around 500 and 600. Smoke has increased from 0.1 to 1, from 0 to 0.1, and it used to be 2 before. What do you aim for when you go to do a tune-up now on an oil burner? How much smoke? What is your target? Zero smoke. You want zero smoke. If you run into a burner that was built in the 60s or 50s, probably you're gonna have some smoke. And that's why the efficiency used to be 80, 70, and now we're aiming for 85 or even 90.
But at this point, one smoke, it's not that bad.
Huh?
At this point, one smoke, it's not that bad.
Yeah. Depending on how old is the burner.
So, where does the last smoke, you gotta replace the whole,
If there's a lot of smoke, you try to adjust the smoke, adjust the air combustion. So you will have maybe 0 or 1, and you adjust for it. If there is too much smoke, probably you have to check and see why there's a lot of smoke. But currently, we want combustion with smoke from 0 to 1. Yeah.
Aren't most gas now, like gas furnaces now more around 97% efficiency?
Gas?
Yeah.
Yeah. But that's not combustion efficiency. That is thermal efficiency. Thermal efficiency is how much heat you are soaking up from the chamber. Combustion does not go up to no. Maximum is 90. You will never be able to burn the entire fuel. And again, pay attention, gas is different than oil. Oil, it's really hard to get more than 90. Still an active area of improvement. They always come up with the new ideas to introduce the right amount of air into the chamber. So it will always change, it always will be something that will be advertised. Fuel pump and igniters. So the fuel pump usually have a strainer in it to protect the pump in case a chip comes out with the fuel and try to go and break the impeller inside the pump. So the pump itself has a built-in strainer in it. If it gets clogged, in some pumps you can take out the strainer and clean it. In other pumps, you have to replace it. The code now calls for an oil filter for most new pumps, so the oil filter should prevent the oil from having any contamination. And a lot of new pumps now are much cheaper and simply designed, so you don't have to take the strainer, and you just depend on changing the filter. Fuel filter is a new practice again. Every boiler, every burner should have a fuel filter coming into it. And again, it will catch a lot of stuff, sludge, particles, chips from the tank, rust, and so on. Regulator valve, that's the oil valve that you always turn on using the primary control. So first of all, you turn on the motor will turn on the fan, air will come in, then in 15 seconds, 10 to 15 seconds, you turn on the regulator valve. The valve will regulate how much pressure and how much fuel goes into the nozzle line. For ignition, we start with 120, 119, 110 coming in, and we get up to 17,000 at between the electrodes. So it's a lot of spark, and the spark should be, the temperature of the spark should be around like 400 to 500. And that's when you see a blue spark. Blue constant spark means like around 600 to 500. You need, think about that, you need 30 cubic feet per minute of air to burn 1 gallon of fuel. So if I have a nozzle, let's see, for example, this nozzle here. If I look at it, what do you see here? Nothing? Okay. This one says 0.75. What is the 0.75?
Gallons per hour.
Gallon per hour. And what is the spray angle? 60 degrees. So 0.75 hours. That means in an hour, we will consume 0.75 gallons. So the flow, the proper flow to burn that fuel will be around 22 to 23 cubic feet per minute of flow. So the fan, the inducer fan will have the capacity to pump in this amount of air inside the chamber. So that's why if you don't have enough air inside the chamber, probably you're gonna have some smoke. If you are using non-sealed burner, which means the air is coming from the basement, you have to have a source of air. Otherwise, you're not going to be able to provide some amount of air. So remember when we talked about sealed burners where the air comes from the outside directly? The burner has an outlet, an inlet where you can get the air coming all the way to the burner from the outside. That would be much better because you guarantee you have a lot of fresh air. Otherwise, you're going to have to get the air from the basement, and that requires you to have a window crack or some kind of vent to suck in air. Otherwise, it will not get enough air, and what would happen is you will have a lot of smoke. And we will see a case where somebody have a fan, like a ventilation fan, that is sucking air outside the house, and that is creating a vacuum inside the basement. And by doing so, you don't have enough air inside that chamber. And if you don't have enough air, you'll have what? Smoke. And that could be one of the reasons. You have smoke, the cat cell might be covered with smoke, and you will have delayed ignition or even more heat. Does this look familiar? I'm gonna point and tell me what are those components. What is this?
Pump. Oil pump.
That's the pump. That's the oil pump. What is this?
Oil line.
Oil line. What about this one?
Shows the flame.
Huh?
It shows the flame.
In a way, this is the airbag. This control how much air comes into the burner. What is this?
Electrodes.
These are electrodes, and this is the nozzle assembly. The nozzle goes in here. What about this one? That's the diffuser. These are always like holding the nozzle assembly in place. What about this one?
This is the
That's the
coupling.
Coupling. That connects the motor to the pump. What about this?
Squirrel cage.
Squirrel cage what? Fan. So this fan will create pressure to bring in air from the outside through the airbag all the way to the nozzle compartment. Motor, transformer, and these are the main components you're gonna have for the combustion.
Wait, what is
That's not even hard.
What,
Yeah.
what is you should do again?
Diffuser, you mean this one? This is give the air tornado effect. So the air will be swirling and it will be shaped. We shape the air, we shape the flame and make it more smooth like this. Any question about the schematic? You already took apart the whole burner and put it back again. So
And-
hopefully you remember.
Yeah,
Yeah.
but I just wonder, the number 4.
Number 4.
Say right
Here, this is the airbag.
What
So-
is that? What is that?
So you see these holes in here?
Yeah.
They're always open. So these air bands have holes in them and have solid parts. So by twisting it back and forth, you can control what is the opening, how much air you get in there.
Oh, okay.
So if I align these solid parts with the holes here, I have no air coming. Less air, almost less air, a very, very little amount of air. If I have the slates here on the opening, you'll get more air inside the chamber. Tanks and piping, that's chapter 3. We'll talk about tanks and piping. This is very important because there will be at least 10 questions in the oil burner exam about tanks and piping. So we'll go over them slowly and try to remember what are the regulations. So the code that regulates the tank piping, it's called NFPA 31. It's in the blackboard. You can skim through it. And they require you in the oil burner to know the information regarding the tank of the National Fire Protection Agency. And the other code is CMR 31. So the national code usually is less than the local code. You agree? But the federal law has to be, the local law code has to be higher than the national code. So CMR is higher, and it requires the maximum size of a tank to be 660 gallons. That's one tank. How many tanks can you have in a house? 2. So what is the amount of fuel you can have in that tank? 1,200 and no, 1,320. Yeah. 1320. You can have 1320, which 2 tanks. You cannot have 1 tank that is 1320. 2 tanks with a maximum size of 660 gallons. Remember this. This question is going to come at least twice in the oil burning exam.
1660 gallons?
No, 660 gallons for 1 tank. 2 tanks going to be 1320. You can have this maximum amount of fuel oil in your house.
That's max, 660.
Yes.
That,
Huh?
That's not.
Yeah. So can you have less than 660? Yeah. You can have less. But tanking is 660, and in 2 tanks you can have 13 and 20. Locations. So in most cases they want to be inside the building, usually in the basement, or the boiler room, or a garage. A boiler room that's for a big building. Probably have a boiler room specifically designated for the
I would think the
for the
garage would
burner.
be safe.
Or you can have it in the garage. What happens if you put it in the garage?
What, warm in the garage?
Huh?
Gonna get cold, right?
Say it again?
It'll get really cold.
Yeah, but it's better than outside, right? It's not gonna be as cold as outside. But what do you do if you put it in the garage? What do you have to do?
All the way to the boiler.
Yeah, what else?
Or like a drain to catch it.
Okay, what else? What else in the garage?
Your stuff.
What do you put in your garage?
Your
Your
car.
car.
I don't know. Well,
yeah,
me neither.
you can't have snow.
Just have to be that.
But if you put it in the garage that's designated to have cars, you will have to put a barrier. Then in case one day the car does not stop for some reason and you don't want to hit the tank.
That'd be bad.
So you have to put physical barrier so you do not hit that tank with your car. Somebody did not back up into the garage or like drive a little bit too much, you don't want to hit the tank. So you gotta have to have a barrier. This question wasn't the oil burner when I took it. If you put the tank in the garage, you have to put a physical barrier that will protect the tank from being hit by the car.
That's
Why you
code?
put,
Yeah.
why you put it in the garage anyways?
You have no space.
No basement space.
Let's say you have no basement. You have no space. It's more convenient. Yeah.
What kind of barrier are we talking about?
Like a wooden one?
'Cause-
No, it has to be a metallic or a cement barrier that will. Yeah. They just ask for solid barriers, so you do not hit the. You didn't hit the tank, and if you hit the tank, it's protected. We have for this tank here that we have in the shop, we are required to have a barrier around it because there are like forklifts and some vehicles loading and unloading vehicles, so we want to have a barrier in there. Outside, above ground, that's another location. Let's say you have no garage, you have no basement, you want to put it outside. You can put it outside, but it's required to have different regulation as well. You'll have to put a barrier and it has to be protected against the elements. We'll talk about that. You can also put it underground, but a lot of people do not want to put the oil tank underground because it's very expensive. Because the tank has to be what? Has to be rust proof, has to be insulated, it has to be protected, and it has to be able to be inspected. So putting a tank underground is possible, but it's expensive. So one other information that you have to remember, that the tank could be 660 inside a house, but what is the maximum amount of fuel you can put in any building, not just residential, in any building? How much? 10,000. You can put 10,000 in any building, not in this kind of tank. Probably gonna have a proper tank inside the house, and it's not for residential. And I get asked, I saw a question also in the oil burning exam. So in any building,
Gallons?
10,000.
That's the most.
That's the maximum you can put. If they say residential, huh?
In a tank?
In a tank, of course. So in a residential, 1320 is the maximum. In any building, 10,000. Let's say we're heating a whole, this building, for example, or building 17. You can put 10,000 tank in there. Okay, I'll stop here and I'll finish the rest on Monday.